Hello. Today we're going to learn a new factoring method, at least new to us. It's not new, it's been around forever. That's called factoring by grouping. And so this is kind of a bridge method that's going to help us get from factoring by GCF to other methods of factoring. One clue that you can use factoring by grouping is when you have something that has 1, 2, 3, 4 terms. So notice here, all these expressions have 4 terms. Your homework will be the same way. Factoring by grouping is kind of like factoring by GCF on steroids, because you're basically going to factor by the GCF twice and then tidy up your answer and make it look pretty. Probably doesn't make a lot of sense right now, so let's look at a few, at least just kind of see where we're going. So, like I said, you're going to factor by GCF twice. You're going to treat these 4 terms as 2 binomials. The first 2 is one set, second 2 is the other set. So I'm going to look at just the first 2 terms right now. What is my GCF there? The biggest number I can divide both 4 and 5 by is 1, and so when we can divide by 1, we don't typically write that. However, I have n to the third and n squared. The biggest power of n I can divide those by is n squared. So my GCF here is 1n squared, or n squared. Now, just like we did in the past, instead of writing divided by n squared twice, I've written it once just because we're going to do other writing here. I don't want to get messy. I'm going to factor out my n squared GCF in front. 4n to the third divided by n squared is 4n. When I divide negative 5n squared by n squared, the n squareds cancel and I get just negative 5. So I've factored the first half so far. Now I need to do the same idea, but with the second half of the expression here. So GCF this time. What is the biggest number I can divide both 24 and 30 by? The biggest numbers I can divide both those by is 6. I can't divide both by an n. 24n has an n in it, but negative 30 does not. So my GCF is just a number this time, just the number 6. It is a positive 6, so I'm going to put a plus 6 in front here. The plus sign is important for the next step. And then I'm going to do the same process I did before. What I get when I divide by the GCF goes inside the parentheses. 24n divided by 6 is 4n. Negative 30 divided by 6 is negative 5. We've done the hardest part of all this. We just need to rearrange our answer into a different format. Our final answers for today are going to look like 2 binomials. So 2 sets of parentheses with 2 terms inside of them. What's going to be inside these 2 binomials? One of the binomials is going to be the 2 GCFs, so n squared plus 6. The other binomial, notice that I have 4n minus 5 here and 4n minus 5 here. It's the same thing. It's not the same thing in both spots. Something has gone wrong and the factoring by grouping doesn't work. So what goes in the other set of parentheses is just this repeated 4n minus 5 written once. This right here is our final answer. Why it works? If I have n squared times this and 6 times the same thing, that's equivalent to n squared plus 6 times that 4n minus 5. If you want to check your work, because hey, you never know, I could be making stuff up, you can always multiply or double distribute. So I'm going to do that really quick. This right here in blue is your final answer, but I'm going to show you why it works. N squared times 4n is 4n to the third. N squared times negative 5 is negative 5n squared. 6 times 4n is 24n. 6 times negative 5 is negative 30. This matches exactly what we started with. You don't have to do what I did here in red to check your work, but if you're ever on a quiz or you just want to make sure your answer is completely right, it's a good way to go. Let's try another one. So, split it into 2 pieces just like last time. Let's do the GCF of just the front part. The biggest number I can divide both 2 and negative 16 by is 2. Biggest power of x out of x to the third and x squared is x squared. So my GCF of the first half is 2x squared. 2 divided by 2 is 1, but it's a coefficient 1, so I don't have to write it. X cubed divided by x squared is x. Negative 16 divided by 2 is negative 8. X squared divided by x squared cancels, so it's just negative 8 there. Second half, out of 3 and negative 24, the biggest number I can divide both of those by is 3. And since it's a plus sign here, it's going to be a positive 3. Dividing each term by 3, 3x divided by 3 is 1x or x. Negative 24 divided by 3 is negative 8. Good idea, check yourself before you wreck yourself. Do I have the same thing in both sets of these parentheses here? Yes, good. That means I'm able to write my answer like I did for number 1 here with factoring by grouping. Like I said, if these don't match, something went wrong somewhere. Factoring by grouping doesn't work. So now let's write our final answer. One set of parentheses is going to be my 2 GCFs, 2x squared plus 3. The other set of parentheses is my repeated factor, x minus 8. I'm not going to go through and check my work, but if you wanted to check it, you could double distribute like we did here for the first one. Let's try another one. So here I have 4x cubed and x squared. It's like a 1 in front here if you want to write that in. Not super important at the moment. The biggest number I can divide both of those by is 1. The biggest power of x I can divide both of those by is x squared. So my GCF is 1x squared or x squared. When I factor that out, 4x third divided by x squared is 4x. Here the x squareds cancel and I get just plus 1. X squared divided by itself is positive 1. Now, so far we've had a plus sign in this location. Now we have a minus sign. The only thing that really is going to slightly change for us is when we have a minus sign here before the second half, we're going to have a negative GCF. So find the GCF and just make it negative. So the biggest number I can divide both 20 and 5 by is 5. But since I have a negative in front of the second half here, I need to get a negative 5. So now I divide both of these things by negative 5. Be really careful with your signs. Negative 20x divided by negative 5 is positive 4x. Negative 5 divided by negative 5 is positive 1. If I wouldn't have made this a negative 5, then this and this would not have matched. However, since we made it a negative 5, these match, which means we can factor by grouping. So, final answer is going to look like our 2 GCFs, x squared minus 5, times our repeated factor, 4x plus 1. Last but not least, at least for this, one more, same idea. What is the GCF of these first two terms? Number part, the biggest number I can divide 8 and 10 by is 2. M part, I have m to the third and m squared, so m squared. When I factor out the GCF 2m squared, I'm left with 8m cubed divided by 2m squared is 4m. Negative 10 divided by 2 is negative 5. M squareds cancel, so just 4m minus 5 inside the parentheses. We need a negative GCF here. And again, we know we need a negative GCF because we have a negative in front of the second half. Now, sometimes people get thrown off here. What's the biggest number I can divide both 4 and 5 by? The only number I can divide both 4 and 5 by is 1. But since I need a negative GCF, I need it to be a negative 1. Negative 4m divided by negative 1 is positive 4m. 5 divided by negative 1 is negative 5. These match, so we can rewrite our answer using the factoring by grouping. First set of parentheses is my GCFs, 2m squared minus 1. Second set of parentheses is my repeated factor, 4m minus 5. Something I didn't address yet, but if you were wondering, does the order matter? No. If you want to write this the other way with the repeated factor first, 4m minus 5, and then your GCFs, 2m squared minus 1 like this, that is perfectly fine. It means the same thing. If you were to do your double distributing, you would get the same answer. Remember that when you're multiplying two things together, order does not matter. That is it for today. Like I said, this will kind of bridge the GCF factoring we've done before, along with what's coming up in the future. Have a great day.